Hey everyone, this is Daniel, and in this video, you're going to learn one of Scala's popular database integration libraries, which is called Skunk. Now, Skunk is part of the type-level family of libraries, which is one of the most powerful toolkits in the Scala ecosystem. It's based on cats and cats effects. So, in order to make use of this video, I recommend you have some cats effect basics under your belt. You can get those either from one of the videos here on the Rock the JVM channel about cats effect, or from the very detailed cats effect course on the site if you're interested. In any case, the best way to make use of this video is to write code with me, and whenever you need to refresh your memory, just to refer back to this video or to the written form at the blog with the link in the description. Speaking of the blog, I have it right next to me here, and we're going to take some code snippets out of this blog and into the code editor in order to run this demonstration. So if you want to spend a productive 30 minutes of your time with a new library under your belt, I recommend that you use this blog next to you and in the code editor. Now, we're going to get started in a moment, but I just wanted to mention my big type-level rite of passage course, which takes you throughout the entire type-level toolkit with all the major libraries in a project-based full-stack course where we write more than 6,000 lines of code and we develop a production-grade jobs board application that I've deployed live on my own website. And this you will write from scratch, including database, including HTTP definitions, including front-end, credit card integration, emails, authentication, authorization, all of these libraries and more. So if you want to check out this course, I'm going to leave that in the description. Okay, back to the blog post and back to the IDE, where I have an absolutely amazing console application called Skunk Demo, which extends the IO app from Cats Effect. You can add Cats Effect by going to your build SBT and adding simply Skunk Core, and this includes Cats Effect as a dependency. And you can add it for yourself by going to the build SBT of the article, and you can add these library dependencies right here where I've just added them. So this is identical. Okay, so you can add this to your own build SBT project when you create an empty Scala project. What else? We're going to create some data structures that we're going to map in a Postgres database. We're going to simulate the concept of a SaaS, so a software as a service, where we almost always have the concept of a user. So I'm going to simply take this case class definition, I'm going to add it here. So the case class user has an ID, email, and name. Okay, then I'm also going to have a config, and this config will be the database configuration that I'm going to store in application.conf. So I'm going to take this final case class config, and I'm also going to add the imports for pure config. So pure config is a library with type class derivation in Scala 3, which is absolutely amazing. And we're going to take all this information that the pure config library will parse from application.conf into this case class, and we're going to pass all these details here to the Postgres database. So I'm going to copy that, and I'm going to paste them here. So we have cats effect, Java util, pure config, which derives the config reader type class, and the derives clause is only available in Scala 3, so make sure you have Scala 3 in your project. So we have config and user. What else? We need a database, so we're going to add a Docker Compose. We're going to store that locally. So back to the blog post, I'm going to take this configuration where it says DB. This is going to be in application.conf. So make sure you have source main resources. So I'm going to delete that and I'm going to create it from scratch. So source main, I'm going to have a directory called resources. And under resources, I'm going to create a new plain text file called application.conf. Now here, the name is important, and I'm going to paste this namespace here. So DB is going to be the namespace, which is going to contain this key value pairing here. Okay, so I'm going to paste it here. Localhost 5432 is going to be the port where we're going to connect to the Postgres database. I'm going to delete the Docker Compose YML. I'm going to show you how to create one from scratch. Okay. Next, we're going to run a SQL script. So it's going to be created whenever the Docker container spins up. So I'm going to take this and I'm going to go to my main project, create a little directory. I'm going to call this SQL. And under this SQL thing, I'm going to create a new file. I'm going to call this init.sql. Now, the name is not important. The important thing is the extension. So I'm going to paste the table creation, which is create table of not exist user, with identical details as was the case for the case class. So ID, name, and email. ID is a UUID. Name is a varchar, or we can use a text here. So name and email. And that is going to be mapped to the case class. So Skunk is a powerful library to map table definitions or schemas to case classes in Scala so that we can write type-safe code in our regular Scala code. All right, so we have init.sql. Then I'm going to take this next one, which is the Docker Compose YML. So I'm going to take this whole thing, I'm going to copy that, and in my root, I'm going to create a new file. The name is docker-compose YML, and the name is important. I'm going to paste this here. And this creates a service called Postgres or database. You can name this however you want. This is just a name. And this pulls the image Postgres. It runs on the port 5432. If you happen to have multiple Postgreses on your local computer, you can run this on another port like 5437. Just make sure that this port is mapped in application conf. So I'm going to use 5437. I think I have multiple Postgres Dockers on my computer, so I'm going to disambiguate between them. And very importantly, the volumes. We're going to have /database table SQL. Now, this is going to be mapped to our SQL directory. So ./SQL is going to be this directory that I've just created. With this init script, this is going to be mounted in a specific place into the Docker container. Be very careful if you are mapping the volume as the file path. You need to map that to the actual file here in the Docker entry point initdb.d. Otherwise, you just map the folder itself, and that's going to be mounted in this directory in the local Docker. All right, so make sure you have that in place. I'm going to create a little terminal here, and I'm going to hit docker-compose up in order to spin my little Docker container. This is going to take a little while. So we're going to have the database. Look at that. We have database-1. And if I add another terminal here, if I do docker ps, we have a bunch of Dockers here. So we have skunk demo database 1. I'm going to say docker exec-it, this little sucker, psql-U docker, or Postgres. This is the user. So I'm going to use Postgres here, Postgres. And this is going to connect me to the Docker container. And if I say \DT, this is going to describe the current database. Now, this is the default database. The database that we're going to use is Skunk here. So I'm going to say \C skunk, and this is going to connect me to the Skunk database as user Postgres. And if I hit \DT, notice that I have a table called users, which is the exact table that we created in the init script. So if I do select star from users, I should be getting an empty table, which we're going to use to store some data. At this point, we can ditch the blog and we can follow along with the code. All right, so let's get back to our main application. We have a bunch of data structures, one for configuration and one for the user case class, which we're going to map to the users table in Postgres. Now, before we connect to Postgres, we will need some sort of connection, which in Skunk, that's called a session. So I'm going to run a little method that I'm going to call single session or get session. And there are two different sessions that we can get in Skunk. One is called single and one is called pooled, that will allow you to create multiple sessions or manage them in a pool if you have concurrent usage of the database. I'm going to show you how you can get a single session first, and then we're going to see how you can change that to create a pooled session. So I'm going to pass a config, so config, and I'm going to use a structure called session from Skunk, session.single. And single will take a bunch of configuration, which is host, port, user, database, password, which is exactly what the config is going to give us. So I'm going to have my host as config host. Then we have port as config port. Then we have user as config.username. Then we have password. Now, password, I think that's going to be an option. So we have password as option string. So I'm going to have sum with config password. And also the database URL. So database is config.database. Now, you may have noticed that this little sucker has a bunch of other configurations, all of which are having a default arguments. And this is not something that we can that we should touch really. So we have session.single. Now, in order for us to do that, we need to be able to pass all these implicit type class parameters. So I'm going to type this with the type argument f, which is the very classical notation in the type level stack. And this needs some type class instances. One is called temporal. This is from Cat's Effect. Then another one is called trace, again from Cat's Effect. Then we have network from FS2. And I think there was another one. Look at that. We have all of these. So temporal, trace, network, and console. I'm simply going to pass all of them here in the type bounds. And the trace is from Natchez. This is another type level library. So this is not from Cat's Effect. So I'm going to import console from Cat's Effect, and I'm going to get rid of the trace from Cat's Effect. All right. So we have temporal, trace, network, and console. These are the type class parameters that we're going to pass in as type bounds in the F type. So session.single is going to give us back, look at the type definition, is going to give us back a resource. So Cat's Effect resource typed with the type parameter F, this is the effect type, and session F is going to be the value that we can use. Now, as I mentioned earlier, we have session single, and there's also session.pooled. And session.pooled gives you back a different thing, is going to be a resource of resources. So a resource that once used is going to give you back bunch of resources as you need, so you can get as many sessions as you want. So we have nested resources here. I'm going to use session single for this demonstration. So we have session.single. Okay. Now, how are we going to obtain the session and use it? So here under run, first I'm going to parse the configuration from application conf by doing config source. This is from pure config default at the namespace db, which is matched in my application.conf. So this is the namespace at which I'm asking the config reader to parse this configuration. So config source default, this is the application conf at the namespace db. Then I'm going to say load of type config. So I'm going to parse that configuration in the case class config, and then I'm going to match that. So in case we get a left, so this sucker, the load method, is going to give me back a result, which is nothing but then either on the left, we're going to have config reader failures, any sort of parsing things, or on the right-hand side, if it's successful, this is going to give me back the case class that I want. So I'm going to go back to the Skunk demo. So in case we have a left with some errors, I'm simply going to print them out. So I'm going to say IO print line, let's say errors, and then that's going to be it, because the IO app simple's run method is going to give me back an IO unit. So simply going to print them out. And in case we get a write, and in case we get a write with a config, then I'm going to run my happy case. So write config is going to give me back a get session. So get session with a config. That's going to be the resource. Then I'm going to use that. The usage is an effect that takes a lambda that gives me back the session that I can run a program with. So here is where we are actually querying the database. So for example, I can say get session on config use, and then I'm going to run a for comprehension where I'm going to yield unit. I don't care about the effect itself. Then I'm going to say, I'm going to have an IO print line opening a session. And that's it for now. And the reason why we have a compilation error is that we have not created or specified the F type. In our case, it's going to be Cat's Effect IO. So I'm going to have IO here from Cat's Effect, and this red dot should disappear, I think. And we have opening a session, and let's run a little query. For example, I'm going to query the date and time. Let me open the terminal, and let me run the query for that. I'm going to say select, and I think it's current timestamp, something like that. Okay, so we have current timestamp. That's it. So I'm going to run this query. So I'm going to have my timestamp as session dot, and the method that I'm going to use is called unique. And the query argument that I'm going to pass here, notice that it is a query type. Now, I'm going to talk about query types shortly. The way that we can build queries is via SQL interpolators. So I'm going to say select current underscore timestamp. Now, in order for the sucker to work, I need some imports, and I hope IntelliJ gives me back, skunk implicits. We have session unique SQL quote. Now, we're going to have skunk implicits. I think I can do better. I'm going to import skunk everything, and instead of skunk implicits, I'm going to use skunk syntax all. And skunk syntax all gives me back the SQL interpolator that you saw earlier, plus a bunch of extension methods. So this import is better. In general, with Skunk, with these two imports, you should be good to go for the entire library. And these are the only two imports that you need most of the time. There's probably one more, which is codec. So skunk codec. And this creates mappings between case classes and tables. So not 2, but 3 imports. That should be all you need. And as for the compilation error, we are missing a trace implicit type class instances for cats effect IO. And the Scala 3 compiler is smart enough to suggest an import, which happens to be the right one, I think. So I'm going to import this sucker, not just trace implicit no op, and that should be good to go. All right. So I'm going to put this import right next to not just trace, and this should give me back the entire thing. So we have session.unique. Now we have a regular compiling error, which is the type mismatch. So SQL quote select current timestamp. Now on the SQL interpolator, I'm going to use a method. I'm not sure if IntelliJ sees that. I'm going to use .query, and the query method will take a parameter of type decoder, which is in fact a codec to turn the Postgres timestamp, which has this wacky format, into a class on the JVM. Now, it just so happens that Skunk comes with some internal codecs, which in this case is called timestamp TZ for time zone. So timestamp TZ is a codec that Skunk comes with automatically. It's from temporal codecs. Now, Skunk comes with codecs for regular JVM types that we use very often. For example, timestamps, local date times, UUIDs, obviously besides the regular data types like string, int, and so on and so forth. So timestamp TZ is just an example of what you can do with the built-in codecs from Skunk. So then I'm going to say print line current time, and I'm going to simply interpolate this timestamp. That's it. So IO print line. And this should be a runnable JVM application for Scala. And this says opening session, current time, 2024, and so on and so forth, the time that I'm recording this video right now. Okay. So this is how we can use a session. We parse the configuration from a config source, and if so, we are going to get a session and then use that resource in order for us to run some computations or some database retrievals. Now, let's assume that we have a user. So I'm going to create a little method. Let's call this insert user or create user, which is something that we would normally do in any sort of web application that deals with users. So I'm going to have user, and also need a session. So session as session F. Obviously, I need an F. And we're going to add the type parameters and the type bounds shortly. So session F, user. This is going to be an F, let's say F unit. Okay. Now, if you want to interact with a database with Skunk, you need 3 steps, essentially. First, we need a codec or a type mapping between the case class and the types for the table that we want to interact with. Second step is to prepare a SQL statement, and then we need to actually run that statement. Now, let's do the type mapping. This is very, very important when dealing with Skunk. So type mapping is done via codecs. Codecs are two-way translators between the types in the case classes, so case classes versus the schema in the table. So if you want to create an encoder, you will create a function that will transform between a case class and the table definition. If you want a decoder, you'll do the reverse. The codec does both. So I'm going to show you how you can do a codec. So I'm going to have codec as codec of type user. And there are many ways, or let's say 3 different syntaxes for creating codecs. Let me show you the basic one. For example, I'm going to turn a tuple of data, for example, the UUID, and then the data type for the name and the data type for email, which are varchar, so varchar and varchar. These are data types from Skunk, so these are representations of the data types in Postgres. Then I'm going to say tupled, and this extension method is enabled by cats. If I create a tuple of 3 things, I can run an effectful tuple on them by importing cats syntax all. So I'm going to put this right up top. So notice that we have the tuple extension method now. So UUID, varchar, tupled, and this essentially turns these things inside out, and we have a codec of these tuples. Now I'm going to map the tuple of UUID string into a user case class. So I'm going to use a method called IMAP. And IMAP takes two functions. One is from the tuple to the user case class, and the other is the reverse, from a case class to the tuple. So I'm going to have IMAP, and I'm going to have the case for ID. So I'm going to have the UID, the name, and the email parsed as strings. Then I'm going to build the case class. So I'm going to have user ID, name, email. That's the first function. The second function is case user with ID, name, email. I need to return the tuple ID, name, email. So UUID is a codec of Java util UUID. Varchar is a codec of type string. Varchar is a codec of type string. This expression is going to be a codec that when it looks at a row in the table, it gives me back a tuple. So we have Java util UUID, string, and string. In order for me to obtain a user, I need to turn that into the user case class and vice versa. This is why I've used this IMAP method. Now, if you're interested, there is a more abstract DSL that you can use. So I'm going to show you another version of doing the same thing. So I'm going to use codec version 2 as a codec of type user. And this is going to be UUID. And there is a method called tilde. So tilde varchar, tilde varchar. And this tilde essentially does the same thing as a tuple. And this expression is going to be a codec of tuple. And then I'm going to have an IMAP. And in case I have an ID, tilde, name, tilde, email, because this tilde also has an unapply that makes it parsable or deconstructible in a pattern match, then I'm going to have my user ID, name, email. And vice versa. So in case we have a user, ID, name, email, I'm going to return this tuple, ID, tilde, email, tilde, whatever. I would simply recommend the first version because it's much clearer because you have tuples rather than nested tuples in this squiggly DSL. But that's your choice. All right. So we have codec and type mapping. Now, we need to prepare a SQL statement and run that statement. We're going to run steps 2 and 3 in the same for comprehension. So what I'm going to do is I'm going to run a for, and I'm going to yield unit. All right. Now, the first thing that I'm going to do is to create a command. Now, the command is going to be done by session.prepare. Now, session prepare is going to give me back, is going to take as an argument a command that has a type parameter. In our case, is going to be a command of user. This is going to be our SQL insert statement. This is going to be SQL, quote, insert into users, or you can write this in all caps if you're used to. So insert into users, values, and then in order for us to parse the right values, or in order for Skunk to put the right values in there, I'm going to open some parentheses, and I'm going to insert the codec inside. So the codec is going to specify which values map to which columns. Okay, so this is going to be the SQL statement. Now, this sucker, the SQL, needs to be a command. Notice earlier that we had query. This command is the insert statement. Likewise, if you have update or delete or things of that sort, you would use the command extension. Now, session.prepare is available to us as an f of prepared query. Now, f needs to have the flat map method for the for comprehension to work, which means that f needs to be a monad. Now, this is from cats. So I'm going to import cats everything, cats effect everything, cats syntax, and so on and so forth. So currently we have f is a monad. If you're not sure what a monad is, I recommend that you watch the cats video or delve into the cats course on Rock the JVM if you want to get really deep into that sort of stuff. Okay, so we have the command. Now, the command is going to be used for us to execute that. And the result is going to be the number of rows that were affected. So this is going to be the row count. So the row count is command execute on the data. And the data is going to be my user. And after that, we may want to log something, which means that we need to have the console type class here. So console, we need to have the console present. So I'm going to say console f print line. Let's say inserted, and I'm going to have my row count, rows, and I'm going to have into the database. And let's use the S interpolator. Now, I'm pretty sure the code will not compile. We'll see why. So let me compile this code. Well, apparently it does. So let's just create a user. So in override def run, I'm going to take this little program here. So I'm going to have a def, let's say basic program with f, which is a monad, and this takes a session as a session f. And this is going to be the for comprehension. And likewise, we're going to have a console. And instead of IO, I'm going to have console f. And likewise, I'm going to have console f. That should be pretty much it. So this is going to be the basic program. And the create user is going to be here. So create user with the session and the user that I'm going to make right now. And this is going to be the user with UUID dot, I think it's going to be random UUID, and the name is Daniel, and then email is daniel@rockthejvm.com. All right, so this is going to be my basic program. So let's try to run this. So we have inserted insert one rows into the DB. Notice that this row count here, apparently IntelliJ has lost track of my types here. So inserted insert one rows into the DB. This is going to be the result of the effect of executing this command. If we go to the database itself, so if we select star from users now, we should get the Daniel thing. So Daniel@rockthejvm.com, and this user identifier. This is great. And you can run any sort of action here, either insert, update, delete, and so on and so forth if you pass the correct codec. Let me show you how you can query the database. So I'm going to have, let's say, a query user with f, which is monad console, which takes a session, let's say session f. And I'm also going to be interested in the name, let's see. So name, and at the end, I'm going to have an f unit. And likewise, a for comprehension where I'm going to yield unit. Okay, cool. Now, what I'm going to do is to get the query. So I'm going to say for query as session.prepare. This is going to be my SQL string. So SQL. I'm going to say select star from users where name is equal to, and I need to be very careful here because I don't need to pass in the name as argument, but I need to pass in the type, and the type is varchar. So the codec that is going to be encoded or inserted into the SQL interpolator, and at the end, I need to run a method which is called query. Likewise, for command, we have query, and query needs to pass the codec for the data type that I'm retrieving for the table, which is the codec for the user. This is the stuff. So query is going to be the stuff that I will end up executing. And this is going to give me back a result. And that's going to be all the users with the name. And because there may be multiple users with this name, I'm going to use a construct called query.stream. So this sucker, if I go to prepare, we have a prepared query, and this prepared query has a bunch of methods. One is called cursor, one is called stream, one is called option, and one is called unique. And we have pipe. This is an FS2 stream that you can use to consume data from the database to other FS2 streams. If you want to take all the items in the database or all the rows in the table that conform to the filter of the SQL statement, you will use the stream thing. So I'm going to have query stream, and I'm going to have to pass the argument, which is name, and the chunk size, let's say 16 for whatever reason. And then I'm going to have compile to list in order for me to return an effect that is going to give me back the list of users. And now I probably need a implicit type parameter. Cannot find an implicit compiler F2G. This is from FS2. This typically means that you need a concurrent F2 in scope, meaning Then I need to change the implicit type class instance here from monad to concurrent, which is far superior from cat's effect, and that should make the compiling error disappear. All right, so let's do the print line. So I'm going to have console f print line found users, and I'm going to have my result there. So let me add that as an S-interpolated string, and that's going to be my query user. So let's use this in the program here. So query user with session and the name, let's say Daniel. Okay, so let's run the application and we should get an instance there. So found users list with user Daniel at rockthejvm.com. If I go to the database and I create another user, I probably need a new unique identifier. So I'm going to say insert into users. I'm going to have ID, name, email, values, and I'm going to take this little sucker. So I'm going to put this in between quotes, and I'm going to change one figure, like 5. And let's assume that this is still called Daniel, and let's have Daniel at google.com, whatever that is. And that's going to be my insert. So select star from users, I should get 2. So users, all right, cool. And I'm going to run my little application. So back to the application, I'm going to run this one more time. And I'm going to find 2 users in my list. So this is going to give me back all the users in the database. So you can now combine all these commands or queries depending on the kind of filters that you want. Now, typically in a web application, when you have a database interaction service, like a library like Skunk, the way that you would refactor these is to use a little class that's called repository. So that's going to be the layer in your application that's directly responsible for accessing a particular table. So for example, I'm going to say a class, let's say user repository. I'm going to have my type parameter f, which has all these type parameters. So concurrent and console, these are the most powerful that we wanted so far. So f, concurrent and console. And then we're going to have the session as session f. And we're also going to have a trait as repository or user repository f. I'm going to design the API here, and the user repository, I'm going to call this user repository live. And this extends user repository f. And I'm going to define the methods here in the user repository trait, which are going to be the create user and query user, obviously without the session. So I'm going to have create user without the session, and I'm going to have the session out. So user, this is going to be an F unit, and find all or find by name with name as string. And this is going to be another F unit. Or you can say F list user if you want. Now, obviously, when you implement this trait, you will override both. So create user and override find by name. And we can bring in this implementation. Obviously, I'm going to take the codecs out. So the codecs are specific to the user repository implementation. So I'm going to pass these. And as for the create user, I'm going to run the for comprehension. I'm actually going to take this entire function and I'm going to place it up top. So codec, type mapping, prepare SQL statement, and so on and so forth. I'm going to just keep the for comprehension and replace the triple questions with the for comprehension because we have the session in the constructor of the user repository live. And the find by name, I'm going to not print out the users, but I'm simply going to return them. So I'm going to take the for comprehension out, remove the query user, and I'm going to put the for comprehension here. And instead of the console, I'm going to yield result, because that's going to be the list of the users that I'm interested in. So this is my user repository live. Now, typically, the way that you would construct the user repository would be via an effectful smart constructor. So in your layer, in your application, you would define a companion object for user repository live. And you define some sort of apply with session as session f, given that the f type parameter has all these requirements. So I'm going to put them here. So apply. And this is going to be an f of user repository live f, or you can return a resource if you'd like that. And I'm going to make the constructor here private so that only the smart constructor can allocate resources here. So allocating a user repository should be an effectful operation. And I'm simply going to have user or new user repository live f with the session as argument. I'm going to say pure f. And the pure is an extension method granted by the applicative type class, which is far upwards in the type class hierarchy, far weaker than concurrent. So we do have access to that. So in my case, I'm going to have my user repository live as the effect that I'm going to use after I obtain the get session. So what I'm going to have here is I'm going to have my repo as user repository live with session. And I'm going to pass in the type parameter IO here. And then I'm going to execute my method, for example, users as repo dot, let me yield units so that IntelliJ can help me out here. So repo dot find by name with the name Daniel. And then I'm going to print them out. So I'm going to say IO print line found users. And I'm going to inject users here. All right. And I can cut out the console from the find by name thing. So I'm just going to yield result. And in this way, I can abstract away the concept of Skunk, and I just use the user repository live as the API for interacting with the database. So this is how we can abstract away the layer that is implemented by Skunk. And at this point, my main method has no knowledge of prepared statements, of sessions, aside from obtaining this as a resource. So I'm going to simply run this application, and we are going to get back the same result. So I hope this makes sense.